This video is a product introduction of the CD33 series laser displacement measurement sensor from Optex FA. The CD33 series is a CMOS displacement laser sensor in a very small, compact form factor. Some of the really great features of the CD33 series are its high accuracy, compact standalone design, it's versatile, it's very user-friendly, and it's also very cost-effective. So what's so great about CMOS lasers and how are they better than a PSD style? Well, a PSD sensor calculates the mean average of the return light spot to determine the peak distance. This average can be skewed if the target material is very shiny or non-uniform, in the case of this example right here. The CMOS circuit breaks down the return light into pixels that can more accurately determine the peak position of the returned light. So we can actually determine the exact peak spot of where the laser light gets returned. Another nice feature of the CD33 series is the high-resolution electronic shutter. The shutter controls to keep a constant level according to reflections. This function enables stable peak level detection even when unstable surface conditions exist. For instance, a black target might not have very much light reflecting back to the sensor. A metal target might reflect too much light and cause an overflow. The electronic shutter helps to maintain a perfect balance between the dark black objects with very low reflection and the metal shiny objects with high reflection. This brief video demonstrates how well the CD33 series laser sensor from Optex can reliably detect slight height differences regardless of color and reflectivity of the target material. The first part is a brass target with 1 mm steps. Notice how on the first step no outputs are on, the second step the first output is on, and the third step both outputs are on. The second part is an aluminum block with the same 1 mm increments. Notice how the outputs are exactly the same as the brass part. The third target is a metal block that has been painted a flat black. It also has the same 1 mm steps. The outputs are exactly the same as the other two. For more information on the CD33, the CD33 CMOS is much smaller than conventional, less accurate PSD lasers. It also only weighs 65 grams or about 2.3 ounces. It really makes it great for online measurement or placing on a robotic cylinder or end effector. Here's the lineup of the CD33 series. As the CD33-30 has a 30 mm standoff or plus or minus 4 mm range, so an overall sensing range of 26 to 34 mm with just a 2 micron resolution. They're all available in 4 to 20 milliamp output, 0 to 10 volt outputs, digital outputs, as well as the serial output option. The next style is the -50 type. It has a 50 mm standoff, and you get an overall measurement range of between 40 and 60 millimeters with a 5 micron resolution. The next one is the 85 type. It has an 85 mm standoff with an overall measurement range of 65 to 105 millimeters. Then we have the 120 millimeter version. It has a range of between 60 and 180 millimeters with up to a 30 micron resolution. And then finally we have the 250 millimeter type. It has an overall sensing range of 100 to 400 millimeters with a 75 micron repeat accuracy and resolution. Again, all of these models are available with connectors or potted cables, and there are individual models with 4 to 20 milliamp, 0 to 10 volts, digital outputs for controls, and serial outputs. Some of the typical industries for the CD33 series include electronics, packaging, construction products, tire and rubber, metal and steel processing, and automotive industries. In the metal processing, here are a couple of ideas. Double sheet detection, confirming proper thickness of metal before stamping, positioning applications before welding, punching, or bending. Some automotive solutions typically could be classification of brake discs, sorting ball joints, proper deflection of CV joint boots like in the picture here, and verifying proper assembly of bearing retainers. In electronic solutions, some of the applications could possibly be measurement of warpage on PCB boards, measure proper component height, verify that components are seated properly. Some of the packaging solutions are checking for vacuum seal on bottling jars, detecting overlapped parts, and background suppression applications. The CD33 series is a fantastic background suppression sensor and can be used for many very difficult background suppression applications that you can't solve with standard normal background suppression sensors. The CD33 series has a very intuitive, user-friendly setup. In the next couple of videos, we'll demonstrate how easy it is to set up and how the bar graph display makes it very nice for setting up and teaching and troubleshooting. One nice feature of the CD33 series is the LED bar graph display that represents the distance of the target to the face of the sensor within its overall sensing range. As I move the target towards the sensor, you'll notice that the lights light and move towards the center of the bar graph display. When I'm at the very center portion of the beam, I get an orange light in the center until I move too close and I get an out of range with the two red lights blinking. This is a very handy feature for determining the center portion of the sensing range. This video demonstrates teaching of the two outputs. This video is a brief tutorial on how to set up the two output teach on the CD33 series Optex displacement laser measurement sensor. For this video, we're using a brass part with a stair-step design that has 1 mm increments. To begin teaching, press and hold the select button for 5 seconds. You will then go into the teach mode. Press the select button a couple of times until you get down to Q1, that's the first output. Move the target to where you want the output to change state and press the set button. Then move the target to the position for the second output, press the select button to go down to Q2, and then press the set button to teach the sensor. Next, press and hold the select button for 5 seconds to go back into the run mode. As I move the part on the slide, you'll see that on the first step, no outputs are on. On the second step, the first output is on. And on the third step, output 1 and output 2 are both on. For more information, visit us on our website at optex-ramco.com. The CD33 series also has an option for serial communication. There is a version with an RS422 serial output. Here is the display of the sensor with serial output. You also get one digital output as well as the serial communication. This right here is an RS422 to USB converter or RS422 to serial converter. We offer many different types and styles that can be connected to the CD33 series serial sensor. For more information on the CD33 series and other great products from